Here we have a set of just 5 elements. Say A is equal to, well, let's call it G. G is E, A, B, C, and D. And this is there's an operation, right, in this set. This is described by this Cayley table. The question is whether this defines a group or not, right? Okay, let's see. It's very easy to check here that E is an identity, right? It's a neutral element, because if you multiply, well, you just can see that this row here is a copy of this one, and that this column here is just a copy of this one. So E is the neutral element, or the identity, right? So this set has an identity. Also, you can check that in every row and every column there's one and only one E, okay? One and only one E, which means that every element has an inverse, right? So the inverse of A is B, the inverse of B is D, etc., right? But while you can see, well, already in this what we have found, you can see that this there's something wrong with this Cayley table, because you have, as I said, A times B equal to E, which means that B is A minus 1, right? But you also have here that B D is equal to E. Okay, BD is equal to E, which means that D is the inverse of B. But that can be because the inverse of the inverse is the first element. So let's put it here, this, so we have A minus 1, right? Because B is A minus 1, okay? And that would be A. So D and A should be the same, and they are not. So something is wrong. And the thing that is wrong is that this product is not associative. And the reason for that is, well, let's see. Let's take, for instance, this operation, A times B. Okay. A times A is B. So what we have is B times B. And B times B is D. So this is D. But if we operate this in this way, what we have is something different. We have A times B. A times B is E. And A times E is A, because E is the neutral. And as you can see, these two things are different. Well, it's exactly the same problem, you see? These two things are different, and because of that, this cannot be true, right? So this is not even a semi-group, right?